Okay, the next thing we're going to look at is how to solve for KEQ. So you're going to be given an equation and you're going to be given some concentrations. And the very first thing you need to do is set up your regular KEQ equation so that you can plug into it. So for this one, KEQ equals, all of these are gases, so I don't cross anything out. I'm going to have SO3 times NO, and there's no coefficient, so we don't need a power for any of these. SO2 reactant and NO2 reactant. Okay. Now I can plug in. It's always easier and best to write this out and then plug in as opposed to just try to look at it, figure it out without writing this out. So SO3, 0.60 molar. NO is 0.25 molar over SO2, 0.15 molar, and NO2, 0.35 molar. Okay, so I'm going to plug that into my calculator. 0.60 times 0.25 divided by parentheses 0.15 times 0.35, and that's going to come out to be 2.85714. Okay, check out my sig figs. 2, 2, 2, and 2, so 2.9 is my KEQ. And remember, the KEQ doesn't have a unit, so it's just 2.9. All right, let's look at another example. This is also calculating for KEQ. So if we're given this equation, and notice that we don't have actual chemicals here, we just have a basic structured equation. Calculate the KEQ. So just like I did in my first example, the first thing I need to do is come up with my KEQ equation. KEQ equals, there's my products, C, D, and there's a coefficient of 3, over A, 2, and B. Okay, now I'm going to plug in. So for C, I have 1.25, 1.25, D, 1.5, remember that's raised to the third, over 3.5 to the second, and 0.65. Okay, so plug in. All right, now I'm going to put it in my calculator. 1.5 to the third divided by 3.5 to the second, and 0.65. 0.529827. 3, 2, 2, and 2 sig figs. The 5's gonna, or the 9's gonna round the 2. 0.53 is my KEQ. Okay. I can also use the KEQ to find concentrations of different elements in the reaction. If I'm given the KEQ and I'm given all but one of the concentrations, I can find the one that I'm missing. Now this requires a little bit more rearrangement of your KEQ, but the math is going to still be the same plug and shove type of math. So in this example, I've got 2A plus B reversible reaction C plus 3D. So I'm going to start by making my regular KEQ because I can tell that I'm going to find A, but I still need to set up the KEQ equation like I normally would. So KEQ equals C D to the third over A to the second and B. And it says in this problem that I'm given concentrations of C, D, B, and I'm given KEQ. I need to find A. So I need to isolate A by itself. So to find A by itself, the first thing I'm going to do is I'm going to multiply both sides by A squared times B to get it off of the bottom. Now, could I leave B on the bottom? Yeah, but I find a lot of times it's easier just to move it and then move it back when you move the KEQ. So I'm going to multiply A squared B KEQ equals C and D to the third. Okay. Now I need to move the B and the KEQ down to the bottom. A squared equals C D cubed over B and KEQ. And I'm not quite done because I haven't gotten A by itself yet. What I have is A squared. So I need to take the square root of both sides to get A just now by itself. So A equals the square root of C D to the third B and KEQ. And now that I have it all arranged, I can plug in to my equation. So concentration of A is equal to the square root of, let's see, C, which is 0.25, D, which is 1.5 to the third, over B, 0.5, and KEQ, which was 4.5. Okay. I can plug it all into my calculator, and it doesn't matter if I do the division part first and then do it in the square root. Oh, it would be helpful if you guys could see. Or if I put it all in with the square root symbol first, you're still going to come up with the same answer. So I get into my calculator, 0.25 times 1.5 to the third divided by 0.5 times 4.5, and then I'm going to take the square root of that, and my answer comes out to be the concentration of A is 0.61237. Go back to my sig figs, 2, 2, 2, and 2, so A is 0.61, and then unlike KEQ, remember concentrations do have a unit, so it's going to be M for molarity. All right, and let's look at one more like this because I know that those ones can be a little challenging, the rearrangement. Okay, so for this one, we've got 2 H2O gas plus, or reversible reaction, H2, or 2H2 plus O2. So the first thing I need to do here, just like always, is to set up my KEQ equation. So KEQ with my my products on the top, H2 squared O2 over H2O squared. And it says, given the KEQ and your concentrations, determine the H2. So I need to get this H2 by itself. Okay? So the first thing I'm going to do is I'm going to get the H2O off the bottom, because once I have my equation in a straight line, it's usually easier to work with. H2O squared equals, oops, KEQ, sorry guys, I got ahead of myself, equals H2 squared and O2. Okay, now I need to get the H2 by itself, so I'm going to divide by O2. H2O squared, KEQ over O2 equals H2 squared. Okay, and then just like I did in the previous problem, I need to get rid of that power of 2, so I'm going to do the square root of this side. And now that I have it all nicely arranged, I can very easily plug in and then solve. So, looking back at my problem, H2O was 0.35 molar, so 0.35 squared. My KEQ was 2.3 over, O2's on the bottom, 0.44. equals H2. Okay. I'm going to plug that into my calculator, and I'm going to end up with a concentration of 0.80 molar for my H2.